Do you know? Did you know, when you start up your computer, a pitch-black interface will be displayed on your monitor screen. This stage is known as pre-boot sequence process. At this stage, all the hardware that attached to the system unit, examples mouse, keyboard, are detected.
Learning outcome. At the end of this topic, student should be able to illustrates the booting process. OS booting concepts. Understanding OS components. Single OS booting concepts. Booting is bootstrapping process that starts operating systems when the user turns on a computer system. A boot sequence is a set of operations the computer performs when it is switched on and load the operating system into memory. Bootstrap loader program, stored in ROM, EEPROM, BIOS ROM. Locate MBR, master boot record, on the hard drive. MBR full bootstrap program is stored in boot disk, system disk, located in first sector on the disk. Initializes all aspects of the system from CPU registers to device controllers to memory contents. Load OS into memory, OS wait for event. OS components, processor manager. BIOS locates MBR on the hard drive. Boot program loads IO.sys and MS-DOS.sys into memory. IO.sys contains more BIOS software. MS-DOS.sys contains software to manage files, run application software and interface with hardware and search config.sys file. Config.sys. First OS file that user can change. Tell DOS how many files it can open at any one time. How many file buffers. Load device drivers. Command.com consists of 3 parts. Code to manage I/O. Internal DOS command. Short program that look for autoexec.bat, automatic executed batch program. Autoexec.bat, automatic executed batch program. Hold a list of DOS commands that are automatic executed each time DOS loads. Loads TSRs, terminate and stay resident programs. The boot process is completed. OS components, processor manager. Pre-boot sequence. Begins when the power is turned on. The computer performs self-check routines and locates a boot record. Post, power on self-test, test memory and subsystems. Systems run post for any devices that have a BIOS. BIOS read the MBR. MBR takes over means that Windows is now in control. MBR looks NTLDR at the boot sector. Boot sequences. Hardware configuration is detected and loaded. And TLDR is the boot loader for Windows XP. Allow memory addressing. Initiate the file system. Read the boot.ina. Load the boot menu. Kernel load sequence. Operating system's components are loaded into memory. Once XP selected from the boot menu, and TLDR run, detect.com, boot.ini, and boot.sys, load ntoscl.x and hal.dll equals greater than located in %system root %system32. Read the registry, choose hardware profile and authorize device driver. Kernel initiation sequence. Windows XP Professional kernel takes control of the system. ntoscl.x takes over. Log on sequence. When the log on to Windows dialog box is displayed and users can log on, winlogon.x starts. lsas.x starts equals greater than display logon screen. OS components, processor manager. C:\NTLDR. Read C:\boot.ini presents boot menu to user. Loads ntroscml.x, hal.dll, bootvid.dll, boot start drivers. C:\system32\ntoscl.x. Initializes kernel data structures, non-boot CPUs, object manager, I/O manager and several other tidbits. C:\system32\smss.x. Initializes the registry using the hives in C:\Windows\system32\config. Starts C:\Windows\system32\cs RSS.x. Starts C:\Windows\system32\winlogon.x. SMSS.x waits forever for CS, RSS and winlogon to exit. If they exit, it crashes the machine. Linux booting sequence. Bootloader, kernel loader, finds the kernel image on the disk and loads it into memory. Task, load the Linux kernel. Grub, Grand Unified Bootloader, and Lilo, Linux Loader, are the most popular Linux bootloader. Kernel image is the management of the system's resources and the software components like process management, memory management, device management and system call. The kernel initializes the device and its drivers. The kernel mounts the root file system. The kernel starts a program called init. Init is the root or parent of all processes executing on Linux. The main purpose of init is to start and stop other program in a particular sequence. Init sets the rest of the processes in motion. The last processes that init starts as part of the boot sequence allow user to log in. Linux booting sequence. Multiple OS booting process, multiple Windows, Windows and Linux. There are two different types of boot process in multiple OS environment. Non-Windows Boot Manager. Windows Boot Manager. Multiple OS booting process, multiple Windows, Windows and Linux. There are two different types of boot process in multiple OS environment. Non-Windows Boot Manager. Windows Boot Manager. Conclusions. Different operating system has varied with their booting procedure and its file. Operating system has an operability running in single and multi-boot.